Okay, now we're going to start with number 6. Clean slate, number 6. Okay, let's go to a different ink color. There's the black. Okay, number 6 says that we have to find the average angular speed of the Earth about the Sun in radians per second. So we know that the average angular speed is omega. Omega is theta over t. So we're going to go 2 pi rads, because that'll be 1 complete revolution, every 365.25 days. And I just said that 365.25 days was 31,557,600 seconds. I just converted my days into seconds, because 1 day is 86,400 seconds. So 2 pi got divided by 31,557,600 seconds, and when I did that, I got 2 times 10 to the minus 7 radians per second. So there's our answer for that one. Okay, number 7. Number 7 says, let's see what we can do here. A car traveling at 30 meters per second, so v is 30 meters per second, undergoes a constant negative acceleration of 2 meters per second squared. And when the brakes are applied, how many revolutions? So we're looking for theta. And we know the radius of each tire is 30 centimeters or 0.30 meters. Come on, cooperate. 30 meters. Man, this thing is not happy. Okay, so I am looking for my theta. So what I said was, well, I know that linear acceleration is equal to alpha r. So alpha is going to be equal to a over r. A was negative 2 meters per second squared, and r was 0.30 meters. So when I did that, I got negative 6.67 radians per second squared as my alpha. And then I said, well, I know that theta is equal to 1/2 alpha t squared plus omega I t. But the issue with that is I'm going to have to do the quadratic, and I don't want to do that. So then I said, well, because I'm lazy and not wanting to do the quadratic, I'm going to say omega f squared equals omega I squared plus 2 alpha theta. So if I rearrange that, theta is going to be omega f squared minus omega I squared over 2 alpha. All right. Well, the only problem with that is I don't know what my omega I is. I know what v is. Well, someone told me that v is equal to omega r. So omega I is going to be vi over r. Vi was 30 meters per second, and r was 0.30. So I can do that now. So theta is going to be 0 minus, okay, omega I we said was 30 divided by 0.3. That's the same thing as 30 divided by 3 over 10, which is the same thing as 300 divided by 3, which is 100. So I think my omega I is 100 radians per second squared. And then my alpha we said was negative 6.67 radians per second squared. So if I did the math correctly, I got 750 radians. But they didn't want radians, they wanted revolutions. So I said, well, 1 revolution is 2 pi rads. Be very careful when you enter this in your calculator. Take 750 and divide it by 2 and then divide that by pi, or take 750 and put this in parentheses, because if you don't, order of operations will bite you. 750 divided by 2 would give you 375, and then your calculator will multiply that by pi, so be very careful. So that's 119 revolutions, which is what they wanted me to give the answer in. Okay, now I'm ready to just move on to number 8. A dog on a merry-go-round undergoes a linear acceleration of 1.5 meters per second squared. If the merry-go-round's angular acceleration is 1 radian per second squared, how far is the dog from the axis of rotation? Okay, well, this one's pretty easy. So A is 1.5 meters per second squared, and alpha is 1.0 radians per second squared. And they want to know what is R. Well, A is equal to alpha R, so alpha is equal to A over R. So that's 1.5 meters per second squared divided by 1.0. Man, I'm having some trouble here, guys. Sorry about that. This should have been R and this should have been alpha. 1.0 radians per second squared. So when I make that division occur, I get 1.5 meters. All right, number 9. Number 9 says a student is swinging a 0.35 kilogram stone. So that's the mass. In a vertical circle, what will be the tension in the rope at the bottom of the circle if the student holds a radius to 0.75 meters? And the speed of at the bottom of the circle is 1.85 meters per second. You would be wise to draw a free body diagram. I'm at the bottom of the circle. So I have the weight, which is mg, and I have the tension. So the tension is going to supply the centripetal force. So net F equals ma. So I have tension pulling in, mg is equal to ma. So what I really have is T is equal to ma plus mg. That's an m, sorry, and that's an a. So since it's moving in a circle, I can know that a is centripetal acceleration, so I have mv squared over r plus mg. And so I just plugged in some numbers that I knew. So I had my mass of 0.35 kilograms. My speed was given to me as 1.85 meters per second. Don't forget to square it. Radius of the circle was held to 0.75 meters. And then to that, I also have to overcome gravity, which is mg, so that's 0.35 kilograms times 9.8. So when I did that, I wound up with a tension that was 5.03 newtons. All right, let's look at number 10, see if we can do anything with it. Okay, number 10. Number 10 said that we had a flywheel diameter of 1.2 meters, and yeah, that's going to be pretty long, so I'm going to stop and start a new recording.